Time to get started. Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Uh, I apologize for forgetting that Monday was a holiday. Luckily, the dean sent out an email telling us you shouldn't have classes on Monday. I'm sure I'm not the only one who might have messed up. And because of that, I didn't have a chance to wish you a happy Valentine's Day. So notice I am wearing a red top. And now something very unusual, a poem from Dr. White. Roses are red, violets are blue. There's no mistake, my students are great. Now you know I'm not going to be a poet, never was. And let's get going. All right. As you hopefully all read, because we didn't have class on Monday, I have postponed the test number one, and that will be this upcoming Monday. Today, what I'll do, which I would have done on Monday, but I'll do it today, is just to give you a heads up. I'll do my world famous review for the next test, this case, test number one. Next, I'll go through problem set 4, which is aromatic compounds. Hopefully you've done that. And then after that, I'll continue on with alcohols, and then we'll do the lab. Now, if you notice, I have a very, how should I say, quick lab. And if we had COD, it would be a quick lab too. So I'm going to steal some time and go. Normally on a Wednesday, I would go to 150, take a 5-minute break, or if we had ECC, we'd take a 10-minute break, go to lab, do our lab, and you're done. Well, I'm going to go later. We'll probably go till about 3-ish or so, but you'll still get out early. You can tell it's a rough day. My third cup of tea, blueberry, wild blueberry from the Republican tea. All right, let's get going. And don't forget, the lab we did a week ago is due today. I've uploaded, ooh, that reminds me, before I do this, I've uploaded your scores. If you didn't hand in the lab, you didn't get one. Uploaded your scores to D2L. I think it's 11 points for each lab. If you have any questions, always feel free to come to my office hours or ask me after class, why did I get this score in a lab? And guess what? You can do the same thing on a test. And next, I better do it today because Monday you're going to have the test. Next Monday, we're going to have our normal classroom, even though I'm giving the test. The way I give tests is I will be uploading to the assignment area sometime over the weekend, test number 1 PDF file. Test number 1 will be a PDF file that's password protected, which means you can't open it up. And after class on Monday, I will send out a password email to each of you so you can open it up. And test number 1, like all my tests, are not open note. So hopefully you've been learning your general reactions. I have put things in my test so I know if students are cheating. Please don't. I will do what's in my syllabus, and you don't want me to do, I don't want me to do that. So please don't. And it's worked out online quite well. Unfortunately, I have caught people, so don't. Because life happens. What happens if you lose internet connection or whatever? And that's happened to me once last semester. I lost it during a 170. Where's my internet connection? Back here is my modem. Be good. But anyways, so what you'll have until next Monday. I'll be giving it to you. You'll have until, I don't know, I'm guessing now, maybe noon on Tuesday to take the test, upload it as a single PDF file to the assignment area of D2L. Now, I think all of you, except one maybe, have got the hang of either using your scanner or your cell phone. On line, I have, or in D2L, I have ways of making a single PDF file from cell phone pictures. Now, if you don't have a printer, which in the last semester, my printer died until I bought that one, which has turned out to be a good buy. It's a single color monochromic HP printer that cost me all of $200 from Staples plus tax, and it was delivered right to my door. Such a deal, and it works real good. It's both wireless and USB. I have to connect to USB, so it's hassles. And if you don't have a printer, on a piece of paper, be sure to write your name, and then for problem one, just put number one, then your answer. You do not have to copy the whole question again. I know those. So that makes your life easier. Also, don't worry about your handwriting. Dr. White's gotten good over the years, how should I say, decoding handwriting. And so far from what I've seen of all of your labs, I have no problem with your handwriting. Just make sure that before you upload it, open that PDF file, make sure you have all the pages or all the questions answered. I've had students in this class last semester and my other classes, I teach at COD. Oh, they forgot they had page 7. I email them back, send it to me quick or you'll lose 10 points. And I didn't do it this semester. Bad Dr. White, because Dr. White's managed a quality control lab for chemical plant, also research at the same time. So I know quality control, otherwise known as QC, and check your email or your PDF file before you upload it. 1, can you read the stuff you wrote, or is it too light? 2, I have all the questions answered in your PDF file. Now, I'd highly recommend, not that you have to, use a pencil, and you can erase if you decide to change your mind. And don't worry if your rings don't look as good as mine. I've been doing it a few more weeks than you have. That's okay. I know what it should look like. And like I said, with the handwriting, try and be clear, but I didn't have any troubles with you. About, was it almost 2 years ago? I had a student who was a special needs student, and he had a very hard time writing. And I could even make out his writing. He'd apologize, and I'd tell him, you don't have to apologize. And all of your writing were much clearer than his, but his was, I could make it out. Were his rings as pretty as mine? No. Well, yours? No, probably not. Maybe, but maybe not. But don't worry about it. Any questions about test? Ooh, I don't know if I went through this, but hang in there 1 second. All right. Hopefully you all see Chem 170, no class on Monday. And then if you scroll down, I might have mentioned this, but I'll do it again. Test number 1, and this is wrong right here. So is this. I'll be giving it on Monday. And you'll have until, I did change it so it's correct. Well, no, I don't have it. You'll have until Monday afternoon. I'll send this out a correction sometime later today. And I'll send out the email with the PDF file password on it. You'll have not until Thursday, I'll have until Tuesday. I have 10 a.m. I'll make it noon. What the heck? I'll be nice. And to upload as a single file. This is not an open notes test. You shouldn't be going on the internet asking anybody else for help. Test number 1 has 13 points, general knowledge. What's the general knowledge question? How many bonds to carbon? Hopefully all know it's 4. Nomenclature. There are 2 types of nomenclature. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. And we've done those in the practice problems. And finally, reactions will be, all but one problem will be, give the product or products for the following. Most of it, except for one, will be only the organic products. And one of these 47 points, or it should be more than 47, will be one of the questions under this area will be, give the starting material or materials for the following reaction. And if you notice, it adds up to 105. So there's 5, yes, 5 bonus points. That's just my way of helping you out. And remember to read how to attach and upload files. Everybody except one person, I think, did it okay with your labs. We'll have our regular lab lecture on Monday. Any questions about test number 1? My speaker's on, so if you ask, or if I'm looking at the chat. Nope, I think everybody's good to go. Any other questions? Going once, twice, and remember, in my class, there's no such thing as a dumb question. And quick public service announcement from Dr. White. Don't forget, tonight, I will have my office hour on Zoom from 6 to 7:15. If you have any questions, stop on by. All questions are always appreciated. All right, let's go to my world famous review. All right, thumbs up, people. Can everybody see test 1 review? Thank you. This is located, this file is a PDF file located in the lecture section of D2L, so you can download it and see exactly what you're seeing on the screen. One thing I should say about my review, once in a rare while, usually I don't, but hey, I don't walk on water unless it's frozen. Even then I stay off. And by the way, I spent a lot of the last, since we left math, a lot of quality time with my driveway, snowblower, and shovel. I hope the rest of my house isn't getting upset or jealous, but I'll work on it this weekend to help them out. But if I missed something on a review, but I've talked about it at least twice in lecture and gone over it in a practice problem, it's fair game on a test. All right, let's get going. First of all, I talked about hydrocarbons. You should know, what is a hydrocarbon? A hydrocarbon is a molecule with only carbon and hydrogen atoms. Next, there's 2 types of hydrocarbons. The first one is a saturated hydrocarbon. Now, a hydrocarbon is a molecule with only carbon and hydrogen atoms, and the word saturated means you only have carbon-carbon single bonds. And it's important to put carbon-carbon single bonds. Next, the other type of hydrocarbon is an unsaturated. Unsaturated means you have a molecule with only carbon and hydrogen atoms. That's what a hydrocarbon molecule is. But unsaturated tells you it has at least one carbon-carbon double or triple bond. Now, I'll never ask on a test, but alkanes are acyclic saturated hydrocarbons. Cycloalkanes are cyclic saturated hydrocarbons. And the A means acyclic, not in a ring. And I taught you how to draw molecules, and using the IUPAC name, also how to First, I taught you how to draw it. Two important things for test number 1 and 2, 3, 4 in the final, you should remember, and it'll always help you. The first one is how many bonds to carbon? Oops, it's broken. How many bonds to carbon? I think I have a deformity there. But anyways, birth effect. But anyways, how many bonds to carbon? 4. Oh, it's on the other hand too. But anyways, you should know there's 4 bonds to carbon. The other thing is, do you break carbon-carbon single bonds? No, except for combustion in this class. Now, I taught you how to determine the longest chain of a molecule that's acyclic, an alkane. I'm not going to go through it because we did that. Then I asked you to learn the alkane names 1 through 10. You should know methane, ethane, propane, on to nonane, decane, and so on, all the ones in between. Then I asked you to learn key alkyl groups. Those are groups of carbons and hydrogens that are attached to the longest chain or ring, as you learn later. And CH3, oh, it's your old friend, the methyl group. 2 carbons, ethyl, 3 carbons, there's 2 choices, N carbon of 3 carbons, and propyl, center carbon of 3 carbons, isopropyl. Then for butyl, there's 3 choices, but I only asked you to learn 2 because the third one I've never used, and you probably won't either. When you have 4 carbons to the N carbon attached to a ring or chain, N-butyl. When you have 4 carbons, 3 carbons are attached to the center carbon, which is the center carbon attached to a ring or a long chain, tert-butyl, but organic chemists are lazy and we call it T-butyl. You can use either on a test. All right, now, gooseline. Anybody go buy some gooseline this weekend? But anyways, did anybody happen to drive by a gas station and think of alkanes, organic chemistry? Anybody happen to light a candle and think, ooh, that's alkanes? Or if your hands were chapped and you wanted to do it either here or you lip balm and use the Vaseline, petroleum jelly, do you think that was an alkane or a hydrocarbon, organic chemistry? Ooh, let's think of another one. Ooh, if you happen to have baby oil in the house, did you look at the bottle and say, aha? You don't have to say the aha part, but that's an alkane too, a saturated hydrocarbon. Remember, organic chemistry is all around you, and it won't hurt to think about it outside of our lecture. By the way, I stole that from SpongeBob. In his cartoon, he used imagination when he was trying to teach Squidward how much fun you can have with a box. Why do I have a photographic memory for things that I shouldn't be? Well, it's a good memory. All right, now you should know real world uses, gooseline. You know they use geese to make gasoline. They call that goose, never mind. Gasoline, propane, natural gas, Vaseline, and baby oil are all alkanes you use in your daily life. Now, there's only one reaction I asked you to learn, and these are general reactions, and you should learn these, memorize these, because you'll need that for test 1. You shouldn't be opening your notes, and I'll know. Now, if you take an alkane or cycloalkane, react it with oxygen, and you need a spark or a heat source, but I don't put it here, you'll get carbon dioxide and water. Remember, organic chemists are lazy. Unless we have to, and you don't for this whole class, we never balance chemical equations unless we have to. All right. And this was in the practice problems we did. Next, I talked about alkenes. That's a carbon-carbon double bond. And remember, alkene has 1 pi bond, 1 sigma bond. Each one of these lines, I don't have it written here, has a pair of electrons. Covalent bonds are always pairs of electrons. So double bonds have two pairs of electrons, one pair pi, the other sigma. Now alkynes are triple bond, two pi, one sigma. That's why you got three lines, triple bond, two lines, double bond. Now, this one should have been the whole ANE, should have a line through it. Dr. White made a mistake and been too lazy to change it. But for IUPAC names, you find the longest chain with both names of the double bond, and then name it as an alkane, and drop the ANE ending, put ENE. For acyclic, you need a number. What's the lead carbon closest to the end of the chain? Remember, when you're numbering a chain, the end carbon, either right or left, is always number one in an acyclic compound, otherwise known as an alkane. Now, if you are in a ring, and plus you'll need cis and trans, and I'll mention that in a while. And for ring, same thing, name it now as a cycloalkane, and then drop the ANE ending and put in ENE. You don't need a number because one of the carbons on the double bond of the ring is one, the other is always two. Everybody knows that. Now, for acyclic, you need cis and trans. For ring, you don't. And the bond angle for a double bond is 120 degrees. And this carbon is attached to this carbon, to this carbon, to this carbon, to this carbon. So longest chain, 1, 2, 3, 4, 5. And that would be pentane. Drop the ANE, pentene, double bond. What's the closest carbon? The carbon of double bonds closest to the end. This would be on 2. This would be 1, 2, 3. Which is smaller number? 2. Oh, by the way, you're not allowed to use any electronic equipment like a calculator during my test. Hopefully you all know how to count up to 10, know which numbers between 1 and 10 are smaller or bigger. Now, notice you have one of either an atom or group of the same on each carbon double bond, and they're on the same side as a plane that's orthogonal, right angle, like if you put your hand there or put your pen right here, and we call that cis.
And this is Tom. I know I've asked this question before,
Ask it again.
but the CH2, CH3, I'm continually getting confused that is an
I,
ethyl group.
I'm familiar with a chain, like a bicycle chain.
Yeah.
Or you can go like this and maneuver it all around, but the links are still connected together.
Yeah.
I won't put in the hydrogens. This carbon is connected to this carbon, which is connected to this carbon with the double bond. And is this carbon connected to this carbon? And the answer is yes, which is connected to this one. And that's how you tell this is the longest chain. It's not straight line, but they're still connected together by the bond. Does that help you?
Yeah. Once I take time to look at it, but my first,
Well, you got to take time in this class. Now, what do you do here? What's the longest chain? Why don't all of you figure out what's the longest chain in this compound? Oh, by the way, it's double bond. Remember, look for what's different, what's not carbon-carbon single bond or carbon-hydrogen. Ooh, I see smoke coming out of everybody's ears. You're working. Oh, that was awful. I'm sorry. All right, let's do it. Tom, do you need more time?
Yeah.
All right, I'm going to steal some tea. Oh, is that good? Wild blueberry from the Republic of Tea. Also, my other favorite, which I had this morning, was their vanilla almond. All right, let's take a look at this because I have things I have to do. This carbon is connected to this carbon, is connected to this carbon, is connected to this carbon, connected to this one, and this one, and this one. You see how this carbon and this carbon are connected, and same thing going this direction. Now, oh, I haven't used blue in a long time. This carbon I'll call 5, and this one I'd call 6. Which is the larger number? Hopefully you pick 7. So the longest chain goes like this. You've got to take the time. You just can't take your first glance and say, oh, it's only 3 carbons right here, and this whole thing is some sort of substituent. No, you have to look at how they're connected to do that. Does that help?
Yeah.
Okay, good. All right. Now, this was cispentene. Let me come down here. Wrong color. And I'll ask all of you, what would be the IUPAC name for that? Remember, cis is same side, trans is opposite side. And good news, you have until next Monday to continue studying in case you need it. Please make sure you do the practice problems because after test number 1, you will find out why Dr. White called them practice problems. Hint, hint. All right, anybody need more time? I think the answer is yes. One more person. I think everybody's done. All right, what's the longest chain? 1, 2, 3, and this is 4 and 5 because these are all connected. And therefore that's pentane, but there's a double bond, so that's pentene. The closest carbon to the double bond to the end of the chain is carbon 2, so it's 2-pentene. Notice we have 2 hydrogens. And if I put in a line, or as we say, an orthogonal plane, meaning a right angle plane, or put your pencil down in the paper, these are opposite, and we call that trans. And that's how you do that. Let's get back to our review. Now, if you have a ring, you need no number, and all rings we use in this class will always be cis, so you don't have to put that down. Now, for a triple bond, again, this should be all of this A and E, the line through it, not just the E. Triple bond, 3 lines. You find the longest chain with both carbons in a triple bond, and you drop the A and E, put Y and E. You'll never, I haven't ever worked with it. in this class see a ring with a triple bond in it. So all the rings will always be acyclic straight chain. You find the longest chain with both carbons of the triple bond, and you name it as an alkane, drop the A and E, put Y and E. You need a number which carbon of the triple bond is closest to the end of the chain, and the rest of the stuff you name alkyl groups like you've already learned how to do. And remember, nomenclature, when you have a name, you go from the right, move left to decode it. We've done it for this chapter in the problem set. Go back and look at my video. Now, reactions. Pi bond, sigma bond. Break pi bonds like that, never sigma. So hydrogen and catalyst, nickel, platinum, palladium, and you break the pi bond, and each carbon of the double bond gets a hydrogen. Everything else comes along for the ride. Since this is the first test, I will do the following. And why don't you write the product or organic product or products for the following reaction? Your turn. And when you're done, give me a smile or a thumbs up or none of the above. Ooh, I forgot to do something. Well, actually, I'm not done with it yet. So let me just give me a second or two, or 10 or 20. Oh, sorry about the delay. All right, let's get back to work. Ah. All right, let's go through this. What do we see that's different? You should always look at a molecule and what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention. Double bond, hydrogen I'm reacting with, and nickel is a catalyst. And Dr. White's about to sneeze, so nope, I stifled it for now. And the general reaction shows us you break the pi bond, remember double bond, one pi bond, one sigma bond, and each carbon gets a hydrogen. Now, the reason I put this up is, do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 across, 1, 2, 3, 4 across. I have 2 methyl groups. Just think about it. 6 months ago, you wouldn't know what I was talking about, but now you do. And I broke the pi bond, and each one gets a hydrogen. And you could have put the hydrogen right over there too. And there are 4 bonds to carbon, so I know how to fill in the rest of the hydrogens. And that's how you do it. The important thing is, do you break carbon-carbon single bonds? No. Once I started brainwashing my students, and I've been doing that to you too, my scores in my class tests went up significantly, like way up. All right, now, if you have a double bond reactor with a halogen, X is how we use abbreviation for halogen. That can be fluorine, chlorine, bromine, or iodine. You break the pi bond of a double bond, and both carbons now get a halogen. Now, what happens if you're adding something unsymmetrical? Well, you break the pi bond, and it'll 4 more rings, and I'll be through. Well, it isn't President Biden, so I won't answer it. But anyways, they gave up early. You break the pi bond, one carbon gets H, the other gets X. How do you know which it is? It follows Markovnikov's rule. The carbon with the most hydrogens in the double bond gets the hydrogen, the other gets X. In this case, fluorine is never used, so it's chlorine, bromine, or iodine. And I don't play tricks on my tests. I won't do that to you. And let's just review Markovnikov's rule. If we look at this molecule, what's different? Double bond. And we're reacting with HBr. Remember, halogens are X. You break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule, that great Russian organic chemist. And that is the carbon with the most hydrogens on the double bond carbons gets the hydrogen, the other gets the halogen. Or as I learned a long time ago, oh, too long ago, the rich get richer, the poor get poorer. And therefore, we look at here, this carbon has 2 hydrogens. This one has 1, which is greater, and time's up. Hopefully you pick 2. I break the pi bond, not the sigma. This carbon at the end has 2, gets the hydrogen. The other gets the halogen, the bromine, and that's how you do it. If you want to make this CH3 and not rewrite this, that's okay. Well, I take extra work on the test. And the same thing happens when you react the double bond. H plus is a way of saying acid catalyst, like sulfuric acid, H2SO4, and water. Remember, water is H and OH. And same thing happens, you break the pi bond. Now one carbon gets the H from water, the other gets the hydroxyl group OH, and it follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other gets the hydroxyl group. And that's Markovnikov's rule. Let me remind you a quick commercial from Dr. White. This stuff here, review number 1, is in a file called Test 1 Review, see how sneaky I am, in the lecture folder of D2L. Now, for triple bonds, we have 2 pi bonds and 1 sigma bond. And now, since organic chemists are lazy and we're not going to balance the equation, we put the letters bracket and the designation bracket, excess, close bracket, and that's telling you you have all the hydrogen in the world that or anything hydrogen react with. If we have a catalyst, nickel, platinum, or palladium, since you have 2 pi bonds, each carbon of the triple bond now gets 2 hydrogens. And the same thing happens, oops, skipped ahead, with halogen. And halogen here can be fluorine, chlorine, or bromine. And here we use excess again, bracket, letters excess, close bracket, that you have all the halogen in the world that will react with anything the halogen can react with, 2 pi bonds. Each carbon now gets 2 halogens, 1 for each pi bond you break, and this is what you get. Next, I talked about aromatic compounds, and this is benzene. If you don't put the lines in front, inside, or a circle, that's cyclohexane, and mark it wrong. Speaking about that, I better tell you this. When you have a ring, you need the prefix cyclo. Common mistake on test 1. Students forget to put this when they're writing the IUPAC name for that. And I give you 0 points because it's not hexane. Same thing here. This is cyclohexane. If I put the bonds showing the resonance structures, or if I use, which Dr. White doesn't like, because I think the first 2 are cooler, but you can do any of these 3 on a test. Now this is benzene. And if you don't put the lines in there, it's cyclohexane, I mark it wrong. If you were supposed to write benzene and you wrote this down without the lines, no, that's cyclohexane. So please be careful on my test. You have plenty of time. Normally in a classroom, we'd have about 50, 55 minutes. If you've done the practice problems, my tests are designated, they're written, so it usually takes my students about 35, 40 minutes to finish. I don't write a test, so the smartest person barely has time to finish, and the rest of you don't do well. That's not fair. And that's against Dr. White's golden rule of teaching. Don't do to my students what I didn't like done to me. Now, when you have a methyl group on a benzene ring, we call that toluene. And let me do this. When you have disubstituted, we use ortho, meta, and para. And later this afternoon, I'll go through all this. We go through the aromatic problem set. And ortho, instead of numbers for 1, 2 disubstituted, remember in toluene, even though it's one name, the methyl group is considered a substituent on the ring. This is only used for aromatic compounds. Do not use ortho, meta, and para for cyclohexane or cyclopentane. No. Next, I taught you some new substituents, and oops. Cl is chloro, F is fluoro, Br bromo, iodine, iodo, NO2 group, nitro. I talked about the sulfuric acid group, or sulfonic acid, I'm sorry, but I won't ask that on a test or the final ever. Now, benzene, which each carbon has a hydrogen, the double bonds gives it added stability, a lot of added stability, and therefore you don't want to break one of those bonds. So you don't. We have what's called electrophilic substitution, aromatic electrophilic substitution. What's ever coming in all these reactions, you take one of the hydrogens off and replace it with something. Halogenation, where X is chlorine or bromine, you replace the hydrogen on the benzene ring with a halogen. Since I'm not going to be giving or teaching you, and I didn't, directors, there's only two problems I can ask you for halogenation when X is chlorine or bromine. Next one is nitration of a benzene ring. Nitric acid, whoa. Hang in there. Two more or one more. Oh, quick thing, personal thing. Some of my students from the other class said, Dr. White, how come you still have a regular landline? I said, no, that's not a landline. That's a Bluetooth phone hooked up to my cell phone. That way, and I've got other satellites of this throughout my house, I don't have to carry my cell phone around. It's set in one place in my office over there, and when I come home, I put it there and I don't have to carry it the rest of the time. My friend always carries his on his belt. His wife carries hers. I don't have to do that. Let's get back to this. Let me finish up. Wrong one. When you nitrate it, nitric acid, sulfuric, remember this is NO2, common mistake. Students say, oh, I see a 3 there, I'll put a 3 there. I mark it wrong. Nitro, NO2 is NO2. If you react benzene with sulfur trioxide and sulfuric acid, like up here and down here is a catalyst. And what do? You get sulfonic acid group, and I'll teach you this group helps make our laundry detergents. That's the way down the semester. And finally, Friedel-Crafts alkylation. I'll never ask you what the name of a reaction is, but I honor the people who discover it, Friedels and Kraft. They take a benzene ring, react with an alkyl halide. R means anything with carbons or hydrogens, aluminum trihalide, and X here is either bromine or chloride, usually chlorine, and you put an alkyl group, R, on a benzene ring. The carbon with the halogen is the carbon the benzene ring will be bonded to an R. And when we go through the problem set in a little while after the break, I'll go through some of these. And I talked about polyaromatic compounds, but that's not going to be on the test. All right, let's try something. All right, everybody, I'm going to ask, I got the same question. All right, for question one, let me see if I can edit it. Hold on, give me about 30 seconds. Yeah, for question one, did you, instead of what it says there, was this helpful? It should have been, I'm still learning polling. Question one, was it helpful? Question two, would you like me to do it again? Put down yes or no for all those. Hi, everybody. It's anonymous. Give you another 20 seconds. Okay, I think everybody's done now. Let's take a look. Most of you found it useful, and most of you want me to do it again. So, back by popular demand for test two, I'll do the same thing. By the way, you didn't have a choice, I always do it. and I also do a long one for the final. With that, I went about a minute over. Let's come back at 1:56 in 5 minutes, and Dr. White's going to go stretch. See you in 5. All right, let's get back to work. This way I can get you out of here before midnight. Ring, 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 ring. All right, let's get back to work. Everybody's back. And what I'd like to do next is go over the aromatic problem set. Before I do that, anybody have any questions on the review? I'm looking at the chat area on my monitor, and the answer is no, but always free to either after class, I'll stick around for a couple minutes, and also tonight I'll have my office hour, so always feel free to stop on by with any questions. Now, everybody see aromatic problem set? Thank you. When I don't ask, it doesn't show up. All right, give the IUPAC name. Remember, IUPAC means the official name. And for this, toluene. Now here, methyl group on a benzene ring, toluene, but I have NO2 nitro. Notice they're 1,2 disubstituted, so that would be orthonitrotoluene. If we look at C, I see, look at C, I see, but anyways, benzene ring. It has an ethyl group and an isopropyl. Notice they're 1,4, you can count 1, 2, 3, 4 that way or the way I did. And 1,4 is para. It's para-ethyl isopropyl benzene. Now, since I'm not holding you to the alphabetical rule, if you put down, don't tell anybody I'm being nice to you, para-isopropyl ethyl benzene, I'd give you full credit. And notice here, I have Cl-chloro. My favorite, T-butyl or tert-butyl. Either one is correct on a test. And they're 1,3 disubstituted, 1, 2, 3, or 1, 2, 3. That's meta. And this would be meta-tert-butyl chlorobenzene. The reason why I'm not holding you to the alphabetical rules, because when you're doing alphabetical, prefixes like tert or isopropyl are not considered. So this is a B, this is a C, B comes before C in the alphabet. If you had put down metachlorotert-butyl benzene, I would give you full credit. Now, when there's more than 2, you use numbers. Like this is that. Remember, 2 of a group is di, 3 of a group is tri. So this is 1, 3, 5 tribromobenzene. And here I show 2 of the 3 possible ways of writing benzene. I could have drawn the other resonance structure here. Remember, put a circle or the bonds inside the ring, or that's cyclohexane, mark it wrong. And if we start from this end and go this way, I don't know why there's a line in there. Here's it's rewritten better so you can see it. I know why, because I made a mistake up here. This C should come before E. Benzene, ethyl, and chloro, they're para 1, 4. By the way, if you put the ethyl here and the chlorine down bottom, that would be correct too. And I have a few more examples. And notice here, I forgot to put the di, bad Dr. White. And benzene, on 2 and 3, you have N-propyl. On 1, ethyl, 1, a benzene ring. Don't forget the bonds. I had a student forget the bonds, and she lost 10 points on different questions because she didn't put in these bonds or circle for benzene ring. And here we have ethyl and 1, 2, and propyl, and another 1, 3 there. Now reactions, these are the only 2 I can give you on the test. Holden. And therefore, here we have chlorination. I didn't write it, it should be X2 FeClX, where X can be chlorine or bromine, and you replace one of the hydrogens with X. In this case, it's chlorine. In this case, it's bromine. Now, I'm going to skip this and come back to these in a second. The only problem I can ask on a test for F is this one. This is sulfonation. Don't forget, this is SO3H. Students put SO3, no hydrogen there, and I mark it wrong because that's something without the H, that's something that doesn't exist. And here we have nitration, HNO3, H2SO4, and you replace one of the hydrogens with a nitro group. Remember, NO2 is the nitro group. Students see the 3 here, put a 3 there, and I mark it wrong because NO3 does not exist on a ring. Now, let's go back to the one I skipped. And this is Friedel-Crafts alkylation, where you react the benzene ring with RX and aluminum trihalide. X here can be chlorine or bromine, and you form a new carbon-carbon single bond, and that's to the carbon that has the halogen. Here, R is methyl, get toluene. Now, here, ooh, look at E. And E, ooh, we have the cyclopentane ring with a chlorine. What's R? The cyclopentane. So replace one of the R's with a cyclopentane, one of the hydrogens with a cyclopentane ring. Oh, let's try this in real life. It's a, and why don't you try this one for your fun and enjoyment on this no snow Wednesday afternoon. I almost said Monday because it feels like a Monday because we didn't have class on Monday. And it's your turn to have some fun. All right, give me a thumbs up when you're done. Give about another 20 more seconds because I think most people are done. All right, let's do this. What do we see that's different here? Ooh, a benzene ring. Remember the lines in here show you it's an aromatic ring. Carbon, carbon, carbon. Ooh, halogen on a carbon. This is RX. This is my R group. Ooh, aluminum trihalide. And Friedel-Crafts alkylation, we make that special thing, a carbon-carbon single bond. The carbon with the halogen is the carbon that this bond will be to. Now, if we look here, it's this carbon. Now, do you break carbon-carbon single bonds? So no. So first of all, I'm going to have my benzene ring. Don't forget a circle or lines. If you do that cyclohexane wrong. Then notice I have 1, 2, 3 carbons here. The end carbon has the halogen. That's the carbon that's going to be bonded to the ring. Oh, let's do one more. And because this is so big, I'm going to write it before hold on one second. Change my mind. And one more for your fun on this sunny afternoon. Yay. And when you're done, give me a thumbs up. See, a couple of you are done, a couple of you are not. In the classroom, I always try and give students enough time to finish it. And I do no differently here. While you're working on that, interesting, the other day, I think it was Monday, I follow a few people, their Twitter postings. One of them is David Korn from Mother Jones. He's the editor of that website. It's a news website, just like Huffington Post. And he had tweeted a professor from California, University of California, I think it was Southern Cal, UF Southern Cal, that had written an article that I missed in the New York Times about he teaches English and he's really enjoying teaching it. He has a good time teaching it on Zoom. I like teaching in person, but I also felt the same way because one of the nice things is I don't have to drive 10 hours a week, which after doing enough driving all my life is a good thing. All right, let's do this. What's different here? Ooh, a benzene ring. What do we have here? What's different? What's not a carbon or hydrogen or carbon-carbon single bond? Ooh, a bromine on a carbon. And that would be Rx. And we have a catalyst, aluminum trihalide. There's only 2 places I know these are used. And I'll teach you both reactions. This is one of them. Remember, X can be bromine or chlorine. What do we get? An alkyl halide, aromatic alkylation of a benzene ring, put an R group on there. We make that special thing, a carbon-carbon single bond, very rare in organic chemistry, very important. What's my R group? This. And so I have my benzene ring. Don't forget the bonds are circle. Do you break carbon-carbon single bonds? No. So you have 5 carbons here. You better end up with 5 carbons. Which carbon has the halogen? The second one. So that's the one bond to the benzene ring. I know there are 4 bonds to carbon. And that's the molecule you get. I moved the bromine over because this is easier for you to write. For me, I could do it either way. That's why I moved it over for you. And that's everything from chapter 4, problem set. By the way, don't forget there's 4 bonds to carbon. Any questions on chapter 4? Oops, there, chapter 4. Look at the chat. Look at my screen. My speaker's on. A couple of times this last semester, and even one this semester. Dr. White, somebody would write in chat, did you hear my question? I look, oh no, my speaker was off. All right, let's move on. Now, what we're going to do is I want to go back to the chapter on alcohols. Excuse me. This chapter will not be on test number 1, but it will be on test number 2, which is coming up down the road, but it is coming up. Don't forget, Monday we'll have our regular class, and then after class, I'll send out the password so you can take test number 1. You have till next day, whatever time I put down, I don't know, noon maybe, to finish it and upload it to the assignment area of D2L. All right, I started talking about this last time we met. Oh, that was a week ago. Wow. Everybody see alcohols, phenols, thiols? Thank you. All right. Now, this chapter, as I mentioned, part of it will be real stinky. Part of it will be very dangerous if you're not careful. And part of it, I'll teach you stuff. Wow, really? Yep, really. Now, alcohols are anytime you have carbon molecule, organic molecule, that's what the R is, with a hydroxyl group on it. OH, I will always use, and also other organic chemists. This is called, I'll never ask on a test, what is this called? But this is a hydroxyl group. Excuse me. See what alcohol does to you? But anyways, oh, that was lame. Sorry about that. So, coming chapters, and this is no different. I'm going to introduce you to the functional group. This is an alcohol, hydroxyl group on carbon. And then I'll teach you the nomenclature. How do we name it? Then how do we draw it from the name? And then I'll talk about real world examples. Then how do you make it? And then the most fun part, how do you react to make new things? Now, I'll never ask the rules, but you should know how to do this. When you have a molecule, it's an alcohol, you drop the E at the end of the name of the chain or ring that has the carbon with the hydroxyl group, name it as an alkane or cycloalkane, drop the E, add OL. If it's acyclic, you need a number. If it's in a ring, that carbon will be number 1 always in this class. And the rest of the alkyl groups are named the same way we've always done it. So let's look at this. And if we look at this molecule, and let me just check, because when I don't, you can't. Everybody see the molecule on my whiteboard? Thank you. All right. What's different? Look at a molecule. From now on, and Dr. White does it instinctively. I've been doing this a few more weeks than you have. I look for what's not a carbon-carbon single bond or what's not carbon or hydrogen. I look here, ooh, oxygen with a hydrogen, that's a hydroxyl group. And it's on a carbon. And what do we call hydroxyl group on a carbon? An alcohol. So now I have to find what's the longest chain that has this carbon. There's only one chain, 1, 2, 3, 4, 5, 6, 7. 7, I hope you know, is heptane. I'm going to drop the E, and because it's an alcohol, we use the OL ending, see at the end of alcohol. Now it's heptanol, and since it's not in a ring, what carbon is it on? If I started from the other side counting, It would be on carbon 5. If I start on this side, it's on carbon 3. And now you have to use your high-level math skills, which is a smaller number, and there you go. Now, if there are other alkyl groups, once you number that 3, you know how to do that. And let's just make sure you do. And the question is 3 points each. Give the IUPAC name for the following. Remember, IUPAC stands for the official name, even though it really stands for International Union of Pure Applied Chemistry. I'll never ask that on test or final. And what would be the IUPAC name for this? Oh, it warms my heart to see everybody working on the nomenclature. And hopefully none of you are having any pain or difficulties, because organic chemistry should be fun. I hope it is. Hang in there 1 second. I'm just doing something. All right, let's do this. Now, if you look at the molecule, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Ooh, a hydroxyl group. The oxygen gave it away. And that's the only other thing. It's a hydroxyl group on a carbon alcohol. And how do we name it? Find the longest chain that has the carbon with the hydroxyl group. 1, 2, 3, 4, 5, or 4, 5, 6, 7, 8. And I hope you all agree 8 is greater than 5. 8, alkane, octane. It's an alcohol, so I use the OL ending. Octanol, which carbon is the hydroxyl group on? Well, here's carbon 2. If I went the other way, 1, 2, 3, 4, 5, 6, 7. Which is smaller, 2 or 7? And time's up. And the answer is 2. So that's 2-octanol. Am I done? No. Because as soon as I say that, this is all spoken for. Oh, look, it's our old friend, the methyl group. And what carbon is it on? If this is 2, 3, 4. So this would be 4-methyl 2-octanol. Now that's how you do acyclic alcohols. How about this molecule? Oh, let me do this one. Let me redo it. I changed my mind in the middle of writing it, and that's not good. If we look here, we say, what's different? Ooh, hydroxyl group, and it's on a ring. This is an alcohol. And how do we name that? That ring, 1, 2, 3, 4, 5 carbons. Pentane, it's a ring, cyclopentane. It's an alcohol which has an OL ending, so cyclopentanol. And since there's nothing else there, and this is always going to be carbon 1, I'm done. And if we had substituents, we'd do it. Number those just like you've done it. And let's try one for you. What would be the IUPAC name for this molecule? 3 points each. Remember on cyclohexane rings, which this is even alcohol, oh, I gave it away, no ortho meta and pair. It's only for benzene rings. And I think everybody's just about done. So let's take a look at this. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Ooh, an oxygen with a hydrogen. That's a hydroxyl group. This is an alcohol. And here we have a 6-membered ring, 1, 2, 3, 4, 5, 6. So that's hexane, it's a ring, cyclohexane. It's an alcohol which has an OL ending. Therefore, I'm going to drop the E, add OL. This is always going to be number 1, so I don't need a number. Oh, look, this is 1, this is 2, this is 3. I have an ethyl group, so this would be 3-ethyl cyclohexanol. Oh, let's do one more. These are fun. And here's one more for you to have fun with. Ooh, that is a pretty molecule. No, you know, Dr. White's an organic chemist. That's pretty. It is. You didn't know molecules could be beautiful, did you? They can. They can also be evil, and I'll teach you later on some evil molecules that have been very nasty to Dr. White in my life. One gave me about 6 weeks of grief trying to solve a problem in a chemical plant. Bad molecule. All right, I think everybody's done. Let's do this. What do we have? What's different? What's not a carbon-carbon single bond or a carbon or hydrogen atom? Oxygen with a hydrogen, and that's an alcohol. and has an OL ending. Well, I've got a ring. And how many carbons? 1, 2, 3, 4, 5. That's pentane. It's a ring. Cyclopentane. And next, you have an OL ending, cyclopentanol. And I see a question, so let me go check it real quick. Somebody beat me to it, sort of. But let's go through this. This carbon with the hydrox group is always 1. Oh, look, on carbon 2, we have not 1, but 2 methyl groups. So 2 you indicate by dimethyl. 3 would have been tri. And they're on carbon 2. When you have di, I need 2 numbers, even though they're on the same carbon. So this would be 2,2-dimethyl cyclopentanol. Remember, this is a 5-carbon ring. Take the time to count each bend. And that's how you do nomenclature. Here's the structure, but there's one more I need to teach you. When you have a hydroxyl group on a benzene ring, oh, that's benzol. No, this had been in use for many eons before IUPAC, and I pronounce it differently. I've had running arguments over with other chemists how to pronounce it. I believe I'm right. And this is phenol. Some of you have heard it called phenol. Now it's phenol. And that's how it's named. And therefore, you should know this. This is the actual common name that became an IUPAC name. And this would be, oh, what's different? Aromatic ring, hydroxyl group. So this is phenol. Now, just like toluene, just consider a substituent. I have an ethyl group. This is 1, 2, 3 disubstituted. So that would be meta ethyl phenol. All right, but the key thing you should remember, benzene ring with a hydroxyl group, the common name became the IUPAC name, that's phenol. And Dr. White, my last patent, dealt with my knowledge of phenol and other things too. All right, now, there are 2 types of nomenclature skills you should have, which means there's 2 types of nomenclature questions on a test I can ask. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. So let's work on that. And on your screen, I'll do this one now, give you one to try. You should all see 2-methyl 1-pentanol. And nobody's screaming at me, so you must see it. All right, how do you decode this to know what to draw? You start from the right, move left. OL ending, alcohol. And here we have, if this were an E, pentane would be 5 carbons. And where is the alcohol in carbon 1? Now, important warning. When I took organic chemistry, my instructor always wrote from alcohols and other functional groups counted from the right this way. You can go the other way. And guess what? Good habits Dr. White doesn't break. So I'm going to always start the rest of the semester, different functional groups counting from the right one going this way. You can go this way, but Dr. White likes to go this way. Either one is correct. So we have 5 carbons, 1, 2, 3, 4, 5. This is where I need pentane. So OL, alcohol, hydrox group. What carbon is it on? It's on carbon 1. Well, there it is. That, oh, it's a methyl group on 2. This is 1. It's better. Oh, I got a feather in my throat. Hold on. I don't even own a bird. That's better. I had a little tickle there. And carbon 2 methyl. And we know there are 4 bonds to carbon. This counts as 1 bond. So therefore, 4 minus 1 would be, actually this one here, 4 minus 2 is 2. And the rest you know how to do. And remember, it's your solemn responsibility now as a member in my class. If I make a mistake, let me know. And that's how you do it. Let me do one more. And how would you draw this OL ending alcohol? And if this were an E ethane, 2 carbons. Well, notice there's no number there because it's impossible to have 2 ethanol. So that's why there's no number. And this is the molecule. Now, if you happen to go into any gas station in the Chicagoland area, you'll see placards by the pump or right over next to the handle of the pump or on top of it. This gasoline contains up to 10% ethanol, which is this molecule. Now, that molecule is a small little molecule, ethanol. And ethanol, and I'm no way implying you should ever do this, is the molecule found in beer, wine, champagne, and hard spirits, you know, the good stuff, Absolute vodka, Canadian Club. Dr. White likes his alcohol. And that's the stuff, if you drink too much of it and don't drink it from gasoline, that'll send you to the hospital real quick. That will get you inebriated, which you should never drive when you're inebriated. And if you're younger than 21, you shouldn't be drinking this stuff anyways. Anyways, true story. Public service announcement. For those of you like vodka, and Dr. White, all 4 of my grandparents came from Russia. I wonder where I learned how to like vodka. The best vodka is either Absolute or Grey Goose. They're like this close together, and I'm a connoisseur of vodka. I've had potato vodka, which is quite good from both Poland and Russia myself. Now, if you want to save money, go to Costco. They have 2 different kinds of vodkas they sell. One is the less expensive American. They have another one they call the French vodka, and it's this close to Grey Goose. I can barely tell them apart. And Grey Goose is for a liter and 1.75 liter is about $50. Theirs is 26. Such a deal. Shh, didn't tell you that. If you're underage, go like this and go, no, 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 so you didn't hear me. How that does that to your body and brain, I have no idea. I'm an organic chemist, not a doctor. All right. And now let's have you have some fun. Why don't you draw the structure for 3-methyl-2-nonenal? Say that 5 times quickly. Don't forget there are 4 bonds to carbon. And when you're done, give me a thumbs up or smile. I think everybody's done. Let's do this. How do you decode this? You start from the right and move left. OLND, alcohol. If this were an E, it'd be nonane, 9 carbons. I better get to work. Where is the hydroxyl group on the alcohol? Carbon 2. You could start from this side. Dr. White likes going this. I'll call that carbon 2. Again, you could have put it on that carbon, but I won't. And next, oh, your old friend, the methyl group. This is 2. This has to be 3. And now there's 4 bonds to carbon. Dr. White will put in the hydrogens at warp drive. And there's your molecule. 3-methyl, 2-nonanol. Let's try one more for you. And from now on, instead of tert-butyl, I'll be just calling it T-butyl, so I'm a lazy organic chemist. And why don't you all try 4-tert-butyl cyclohexanol. Yeah, it looks like everybody's done. Let's do it. How do you decode this? You start from this way and go there. And if this were an E cyclohexane, oh, that's a ring. And cyclo, ring, hexane, 6 carbons. One of the carbons, because this is OLND, tells you alcohol. And I'll call this carbon 1. Most of you will. I could also put it on any carbon, but most of you are going to put it on the top carbon. This is 1. I have a tert-butyl or T-butyl group on carbon 4, and this is 2, 3, 4. And we have 4-T-butyl cyclohexanol. And that's how you do nomenclature, IUPAC nomenclature, excuse me, of alcohols. Now, we're getting into different, more mature or functional groups that have been around for a long time. And we have what's known as common names. And common names, My mustache is tickling my nose. I'm going to have to trim it, excuse me. But anyways, common names are used in key alcohols that the common name is more likely to be used than the IUPAC name. And a common name is derived by naming the chain that the hydroxyl group is on as an alkyl group and then adding the name, alcohol, at the end. And I'll show you that. Now, one thing on my test and the final, when it comes to common names, I'll never ask you, here's a molecule, what's its common name? I won't do that, but I will ask you, here's the name of a common molecule, know how to draw it. Why? Because an added benefit for my classes, by the end of the semester, you can pick up things you buy in your daily life and know what the structures are. And I've taught you a little about MSDS sheets, and I'll talk more about this semester. And you can look them up and say, do I really want to ingest that product with those molecules? Or do I want to put it on my skin or my hair? Maybe, maybe not. Then you'll be able to tell. All right, let's look at the following. And go a little over where we normally take a break and go on a little because we'll finish the lab. I'll get you out of here by 3 o'clock, if not sooner. So hang in there. Not the prettiest chart, but on a whiteboard, I can do the same. All right. First of all, everybody see it on their screen? Thank you. All right. If we look at the first one, the IUPAC name is ethanol. But if we look at here, here's my R group, that's an ethyl. Common name, which you'll also see, especially on bottles of wine, is ethyl. Named the R group as an alkyl group, and alcohol. By the way, for those of you who haven't tried it, the German white wines are quite good. Most Americans don't know about them. And Dr. White, having worked in Germany, knows some of the good ones. If you go to Binny's, the Pierce Porter, Golden Trocken Cabernet, and Spätlese and Auslese are excellent wines. They have been for decades, and they're not that expensive, and they're real good. All right, next one. 1, 2, 3 carbons. Propane. Alcohol, propanol. The hydroxyl group is on carbon 2 propanol. But if we look at this R group right here, oh, it's an isopropyl group. And the common name would be isopropyl alcohol. And if I can spell it right, and if you work in industry, we just abbreviated IPA. And if you take 70% isopropyl alcohol, and about 30% water, you get a homogeneous solution, which we call rubbing alcohol. And if you have certain irritations, you can rub this on your skin and it helps with that because rubbing alcohol will kill certain bacteria, I think, but viruses I know, including COVID-19. And if you go to Walmart or other big box stores or even Walgreens, and I don't get kickbacks from those companies, shucks, I wish I could, you'll find they now have even rubbing alcohol where the isopropyl alcohol is high as 90%. And you should know, if I write on a test, draw the structure of isopropyl alcohol, you should know how to do this. Now, this last one, if we look here, the longest chain, 3 carbons, propane. It's an alcohol, propanol. It's on carbon 2, plus I have a methyl group on carbon 2. And the IUPAC name, which nobody uses, 2-methyl-2-propanol. If we look here, the way I drew it this way, what do I have right here? A T-butyl group, and everybody calls this T or tert-butyl. Most organic chemists are lazy. T-butyl. Alcohol. And if I write this on a test, draw the structure of T-butyl alcohol, you should know it's this way or this way. All I'm doing is rotating it 90 degrees. So these are common names you should know. Ethyl alcohol for ethanol. Isopropanol is really 2-propanol. And T-butyl alcohol is this structure. And here's the IUPAC name nobody uses. And that's common names. All right. Normally we take a break and then I'd come back and let's go 5-7 more minutes and then I'll let you out because on a lab day you usually get out early. Everybody with me on that? Unless you want to sit around for 5 minutes. I wouldn't. All right, it's lab time. And today's lab is super quick, which is why I can get you out. And if we were in the lab, which I wish we were, it would also be super quick. Now, what's today's lab? And today's lab deals with aromatic compounds. Everybody see that on your screen? Thank you. All right. Now, aromatic compounds, as I mentioned when we first started, were very and still are very important compounds in our daily life. In the 14th through 1700s, wars, yes, wars were fought over aromatic compounds, and a lot of them are spices and the lands where those spices were grown. And huge fortunes were made because of the sale of that. Columbus was looking for a quick way to get to India to buy spices and obviously didn't find it. He found America, unless you believe in Leif Erikson was here first, which is a good possibility. Is which was right? I don't know. I just think both. All right. Now, many spices and plant extracts have a common chemical feature. They contain an aromatic benzene ring. And those are things which we call eugenol, vanillin, I should say, benzaldehyde, and trans-cinnamon aldehyde. Now, if we were actually in the lab today, you'd be using an important chemical instrument, analytical instrument that you brought to the lab, your nose. And you would be smelling the following. If you have these at home, smell them. If not, and that's a sad thing, I'll ask you to smell cinnamon, cloves, nutmeg, vanilla, and I'll talk about benzaldehyde myself. And if we were in the lab, if it's a liquid, we put a little on a piece of paper and then place that paper underneath your nose and smell it. If it's a solid, open the bottle and then smell it, or like with cloves, rub your fingers a little on it and smell your fingers. And this is what we would do. And it's fun. Now, for those who have never smelled cloves, which maybe some of you. I've had students say it smells like their Christmas ham, reminds them of that, because a lot of people, when they cook hams, will put cloves, stick them in the ham, and it gives it a distinctive smell and flavor. Now, Dr. White put down dentist's office. Yeah, dentist's office. Now, if you've ever been to the dentist, and hopefully maybe you haven't, but you've had to have a shot before they do work, major work. And I have to say, in my family, it's hereditary, bad dental problems, and I've had them throughout my life. My sisters have, my mother, father both gave it to us, my grandpa, whatever. And first of all, if you have a good dentist, really good one, before they inject you into your gums with the Novocaine or whatever they're using, that anesthetize your gums and your teeth so you can do stuff on there. Yeah. But anyways, they rub something on your gums. So that way you don't feel the needle going in. Even though they do use super fine needles, you still don't feel it. And what are they rubbing on your gloves, on your gums? Oil of cloves. The oil from cloves has a special effect to anesthetize your skin or the topical layer of your gums so they can do that. And that's why, for Dr. White at least, whenever I smell cloves, I can think of all the times I've had to have that done. Because when they rub it in there, you can smell it coming out of your breath. And the cotton swab, as they're pulling it out, you can smell it, or also when they're putting it in. So that's my own impression of what it reminds me of. Now, for benzaldehyde, that's an organic molecule. And here, for those of you who haven't smelled it, benzaldehyde is found in both cherries, like maraschino cherries. Those are the red ones you put on top of a sundae that glow in the dark because they have so many chemicals in it. But anyways, I love them. And Dr. Pepper, I love Dr. Pepper. I also like uh, Werner's ginger ale, but Dr. Pepper, yeah, I'm a doctor and a Dr. Pepper too. And almonds, especially mascarpone, which is almond paste. And if you've ever been in Brussels, which I have, some of the candies and uh, bonbons and everything that are made from mascarpone. Brussels, they have a big area, about a 2 block area of the finest candy stores in the world. It's a dangerous place for me to go to. And they have actually walk-up windows where you don't even have to go in the shop to buy stuff. Dangerous. So whenever I smell benzaldehyde, at the same time, I can smell Dr. Pepper, I can smell almonds, which I also like. Now, I think most of you have smelled cinnamon, nutmeg, and vanilla. Vanilla extract or vanilla extract is made from the vanilla bean. And the best place to buy that, let's see. Somebody have a question, or your microphone is, all right, whoever had their mic on, whatever. Anyways, that's not what I wanted. Everybody see the Spice House on your screen? Thank you. And if you put it in here, I spell it right. Now, this stuff is pure pleasure. Dr. White's a vanilla vanillin or vanilla extract free. And if you notice the price, 4 ounces, $42, 8 ounces, $82. I usually get this one, lasts a long time. This is double strength. And once you use this stuff, you'll never go back to the garbage you buy in the supermarket. And their stuff is amazing. Since I've been a little kid, I'll take some of this, put in some water and a little sugar, and it's just like an uncarbonated cream soda. You don't know what a cream soda is? Boy, are you missing a lot in your life. And this is available. Now let's get back to our lab because I promised to get you out by 3-ish. And nutmeg and cinnamon you should also look at. Now I have some questions. And one of the questions are, so you learn about these things, draw the structure of the key aromatic compound found in the spices or chemical. And enclosed, that is the common name, eugenol. In cinnamon, that's tranexamic acid. By the way, I love cinnamon. My older sister hates it with a passion. Nutmeg is similar to cinnamon, and in structure, you should look up isoeugenol. Vanillin is found in vanilla extract, and benzaldehyde, which I said is the smell in cherries and almonds that you smell. You can look it up by just going to Google. Don't forget question number 3, what's your favorite spice or aromatic chemical? And that's lab on aromatic compounds. Oh, it's 3 o'clock. I said we'd be done by 3 o'clock, and I've caught up. We're in a good place. Remember, Monday, test number 1 will be given after our lecture. So come here for our lecture from 1 till 3:50 or 3:40, because I end a little early because we only take a 5 instead of a 10-minute break, like we would if we were at ECC. And don't forget the lab you did last Wednesday is due today, sometime today. By the end of the day, try and get it in early tomorrow morning. And with that, we're done for the week. I'm going to say, Gang gesund, goodbye, bye. And if you have any questions, come to my office hours tonight. And don't forget, if you have a chance today, tomorrow, or over the weekend, smell those aromatic compounds. I'm sure a lot of you have cinnamon, vanillin extract, or nutmeg in there. If not, see me and I'll help you out with what it smells like. Okay, bye now. I'll stick around if anybody has any last minute questions.